Hello there, I'm going to try to show you how to use the regression and Hopper design workbooks. So the first thing we need to do is regress the data. So we can open up the spreadsheet, the workbook, and generally what I like to do is the flow function and internal friction first, and I will always do linear, at least for starters. And what I need to do is cut and paste the data that we have from the FT4. So I've already done the cutting. Let me paste some data. Here we go. And we see that the correlation coefficient is pretty good. I just kind of glance at that. It doesn't have to be perfect. But every time I perform a regression, I hit the right button. In this case, it's the flow function. I'll click the flow function button, and that's going to load everything up onto another page. I'll show you that eventually. We'll do the same thing for the other data. Let me show you the delta. I've already input everything. And it's kind of an odd relationship, but here it is. We hit the delta button, etc. We do everything for the bulk density. I know we don't have a whole lot of bulk density data. We only have one data point, so I just kind of made up some more just for this exercise. We'll click the bulk density tab. Wall friction, we need that for the rat holding calculation. So we'll need to get some wall friction data. I generally like to use the quadratic tab. So this is some hypothetical data. Again, once I've entered the data, I will hit the right button. I've already done this. Once I'm set and done, I didn't mention internal friction. That goes on the linear as well. We'll go to this tab that's marked regression coefficients, and everything that we have calculated, everything we regressed before is all loaded up, ready to go. We click the copy coefficients button, and now we can go to the Hopper design workbook and see here there is a button that says paste copied regression parameters. We do that. I've already done that previously, but here it is. It's all loaded up. And now we can go ahead and calculate arcing dimensions and rat holding dimensions, hopper angles for mass flow. So the hopper angle, the mass flow hopper critical arcing dimension, the dimension we need to meet or exceed to prevent an arch from forming in mass flow. We just click one button, and here we have the answer. And your material is really cohesive, and we get an answer of 900 millimeters to prevent arching. Obviously, we're not going to be able to design a very good bin, but this is the material you're handling. Go back. Now, if we want to calculate the hopper angle required for mass flow, I went ahead and entered the outlet dimension that you have above your screws, 0.048. And this is for conical geometry. Now we'll go ahead and step through. The flow chart is right here, but it's just a matter of clicking the buttons, and we'll proceed. And what I like to do is I try to keep track of the hopper angle. We need to converge to a solution. It usually takes a couple of iterations. So I'll just go ahead and click, go through the routine. I'll keep up updating. And we're off by a little. Before I think we had like 10 degrees here. We're now about 8. So I'll do it one more iteration. And 8.2 degrees. So obviously this material is not going to not be able to be handled in a conventional hopper. You'll need to have some kind of special flow aid and preferably a planar geometry, but that's not what you have. So let's go back home. We'll go ahead and calculate the funnel flow information. So we click on funnel flow, hopper design, and the critical rat holding diameter is going to depend on the geometry upstairs. So we go here, normally we go to the Johnson equation. And I went ahead and already entered the hydraulic radius is equal to the cylinder diameter divided by 4. But because you have such a short cylinder, instead of using the Johnson equation, because the Johnson equation just tells you when you have a deep, tall cylinder, then the rule of thumb is to use this equation here. We'll go ahead and calculate that, press the button, and now we get another enormously large rat holding diameter. So the bottom line is, man, if you have convergence, you're going to be in trouble. I know you have a little bit of convergence in the feeder because the way it looks like, you have the agitator below a converging section. It might reach the agitator because that distance is pretty short, but it's kind of risky. But in any event, what I wanted to do here is show you how to use the spreadsheet. And I hope this is helpful. Give me a holler if you have any questions.